the system itself maybe might take us $10 or $12, and this is in lots of 100, and maybe sell for $60 or something like that. If we go lower production, we're talking $10, $12, $13, and we can actually sell it for a little less. So there's a good markup. There's good money to be made in this. And remember, this is a new technology, brand new technology that will be needed, like the cell phones. Cell phones are needed. People need those cell phones now. We'll make this technology, actually this technology, drive the industry, if you will. I'm going to talk about this health light that we're designing for NASA. This light, or lights, essentially has a small, if you will, collector that'll sit inside. Here. And the collector sits inside and actually collects power through there from different devices. Advantage, it tells you whether there's electromagnetic energy that may be harmful to you. It gives an alert. This is something NASA is very interested in. Let me just take this out of here. Nice product. Very inexpensive. Injection molding, all these things. Nickels and dimes. Manufacturing background. My manufacturing background stems all the way from Hughes Aircraft to Allied Signal. I worked for Motorola, just-in-time manufacturing. Motorola and assembly lines for a lot of automation with robotics, and I have done some also offshore in Mexico manufacturing. Once again, let me stress the point that we plan to not do any manufacturing here at our facilities here in Irving. We're not geared up for it. We're not set up for it. We have people with big equipment that can do that, and that's how I believe we make the money. So we may do licensing, integration, and some assembly, but more than likely we'll probably do all of everything offshore. Let's talk about some other products. And once again, before again the products, trade secrets, how we put it together, things like that. We have a pretty good handle on it, and we watch it really closely. Of course, other products could be the computer. A computer. Imagine a whole bank of computers with no cords. You say, what about RJ45 cords? What about mice? All sorts of connections to the back of that machine. All those can be eliminated using our system. How's that done? Well, easily the computer can get power from a pod, little pod sitting in the corner. You have a collector built in the computer. One of the nice features of the collector and the pod is that we can essentially modulate that signal onto the signal that we're transmitting to the collector. So along with the power, the internet signal comes. In fact, we're talking to people about building a tower, and we have a concern that we're working with this. Charging electrical cars, lighting, portable tools, underwater application, hazardous areas, clean rooms, cell phones, tremendous, robotics, Honda, nice robot, great robot. It's very heavy, pretty heavy robot. It has a lot of batteries in it. Too heavy. Only lasts 27 minutes. We can provide power to that unit, robot. Nice products. So essentially, I was hoping to just sit down and give information about pods and collectors, some of the business plans, concerns about patents, concerned about health, radiation. Those seem to be the big issues. Does it work? You bet. Works great. Good proof of concept. Nothing wrong with this. I showed this to senior scientists that wanted to actually see incandescent light bulbs for work. We connected some little toys up to this, especially this guy right here. Made some little cars running around. Has a nice, very nice number of applications. It produces real power. Okay. For us in lighting, fine, great, but other than that, Also, it produces real power that can be used. Blow dryers, hair dryers, all sorts of things. It's just a matter of maybe size, how you put it together, how you tune it, and things like that. I wanted to talk a little bit about muscles and some different vision systems and G-pods and things like that. Muscles, I've been working with prosthetics for quite a long time. Once again, you can build the best muscle in the world, and I think we do have a great muscle. We have polycarbonate muscles. We have other types of devices that use no O-rings. A patent on a cylinder uses absolutely no O-rings. Zero breakaway. Great little product. You can hit these, you can bend them, you can do what you want to, and they still work. Very nice product. Another muscle product is what we call a peanut actuator. Nothing like this on the market. We have a patent on it. Looks like a peanut. Goes around the arm. Works very well. This is made out of aluminum. It's a little heavier. And our polycarbonate actuators and our polypropylene actuators, and we have numerous types of plastics we use for actuators. We're the only ones that build that particular type of actuators in the industry. Why? Lightweight, very hard to destroy them. Chemicals don't attack a lot of different types of plastics. So there's some really nice features to do with the muscles. We also have a small bio-type chemical muscle that we're working that is very much like the muscle that we have in the human body. Be excellent applications for amputees. Power systems. Power systems, of course, the pods and collectors. Vision systems. We have a number of patents and projects we're working on. It's what we call a pulse wave disturbance system. So what we have is a vision system that essentially detects electromagnetic signatures throughout the Earth, and everything has electromagnetic signature just like a DNA. We basically detect that signature. We run it into a certain type of transducer, which is no more than a disturbance field setup, if you will. That goes into a computer. Software sort of straightens it out or descrambles it, if you will, and presents a picture on the screen. We actually can take a picture in, let's say, Argentina, a few minutes old, a few seconds old. Well, through our system, we actually take that electromagnetic energy that's traveling around the Earth at a constant rate of speed. There's some real key things in here, but I won't get into them. But if you can capture that through a disturbance system, like I said, unscramble it and use software, you can actually take a picture. Pretty amazing device. There would be no more airport security problems with that device. None, absolutely none. Because we can detect any kind of, let's say any kind of mass we want to. Let's talk about G-pods. What we call ground pods. Of course, power on demand pods. Pods are just called G-pods. G-pods are ground pods. They transmit a tremendous amount of electrical energy through ground waves. So what happens is the pod actually has a device that puts this energy down through the ground, and then we actually pick it up miles away. Of course, nothing new in respect. Tesla did this 1800s, 1820, something like that. I think it was documented in the New York Times. You can check on his patents. A lot of them are applicable. Only the fact of concept. Our ideas and his ideas are somewhat similar in a sense, but we're using a different technology. We're using what we call pulsed wave energy technology. It's quite a bit safer, quite a bit better, regenerated better. There's not, well, he used a lot of ozone. He created a lot of ozones and coronas and things that did a lot in the air. We don't do that. We completely do things different. Uses a lot of spark gap. We